This is Chris Carlson, here to answer some of the questions that came in during this presentation. So we'll start off with one from Jim, who asks, for manipulators, is there a way to both label and include step size for a slider control? Yes, there is, and this may have been answered in the presentation after the question came in, but I'll answer it again. So if I have here manipulate x0 to 1, that gives me a slider. But you can assign an initial value to x here, say 0.5. It'll start in the middle. And you can also specify a label as well, value, if you don't want the default label of x. The step size then goes here after the end points of the range. So for example, if I wanted to go in steps of 0.1, then now we have a slider whose initial value is 0.5 that goes in step sizes of tenths and is labeled with a different kind of label. From Malcolm, the question, can manipulate be used as part of a chain of APIs, as in invoke it in an app and use the output after user interaction in an API further down the pipeline? Okay, there's several interpretations of that question. Let me attempt to answer it. So one way of doing that is you can actually manipulate manipulates. So for example, if I have here manipulate x and say x, let's let x go range out now over a list of values 1, 2, 3, and say, let's just look at that first. Okay, so that gives us a setter bar that has the values 1, 2, 3. And now let's manipulate that manipulate. And I'm going to choose a control type and let the outer manipulate determine the type. And I'll let that be, it can be a setter bar. It could be a radio button bar. It could be a slider. Okay, so now I can choose the type of this control with the outer manipulate. Okay, another interpretation of that question might be, can you change the configuration of a manipulate's interface from within the manipulate? And you can do that as well. So an example of that would be this. If I say manipulate, let's see, let's manipulate x and y, and let x go from 0 to 10, say, and y go from 0 to 10. Okay, now I have these two sliders. But suppose I want the range of the y slider to be a maximum of the value of x. So if you can just put x in here, and it'll have that behavior. So now y goes initially from 0 to 0. Since x is at 0, it doesn't move. But if I increase, say, x to 2, now y has a range of 0 to 2.74, and so forth. And you can see as I increase the x value, the thumb of the y slider is going to move depending on what its maximum value is. And if I decrease the x value down below the current value of y, I get this red indicator that that the value of y is out of range. A third possible interpretation of that question would be this. Can you change the configuration of the controls of a manipulate from within a manipulate? And an example of that would be this. Let's say manipulate n. Let's show n and, well, let's just show n initially. And let n range over a number of integer values. Okay, so that now n chooses that value. And now let's let n control the number of, say, slider controls in the interface. And the way you do that is you insert a dynamic within the manipulate, and the dynamic has a dynamically configurable set of controls. So for example, say I want a column of sliders. So I'm going to make a column, and I'm going to put a table of things in here, and the table is going to be n items. N is the value determined by this control, and I want each one of those to be a slider. And the way you specify that in this context is to use the control construct, and then you just give it the arguments as if this were a slider control. So let's say I want x to go from 0 to 1. Okay, now I have a manipulate where the first control chooses the number of sliders that I have for the value of x. Now in this case, all the x's are ganged together, which is probably not what you want. But you can have controls for several different variables where they're not all connected. Okay, now a lot of questions have come in. Let me just have a look at the list here. One more, I'll take one more question here. So Osvaldo asks, can manipulate access in external data files, for example, text, Excel, MS-DOS, exe programs, and so forth. Manipulate can manipulate anything that can be expressed as an expression in the Wolfram language. So you can have an expression that reads a program, or reads a data file, for example, which might be determined by the values of the controls, the other controls in manipulate. So yes, you can access data files, and in fact, if you have a programmatic connection to another program, say via math link, then you can manipulate things that you can access via the math link as well. So our time's up for questions. Thank you for the ones you submitted, and we'll go on to the next presentation.
Let's see, there's one question from Stefan. Let's take a look at that one. This gauge we saw is surely only one kind of visualization of analog data. What other controls are there? Let me read that question again. This gauge we saw is surely only one. Well, I mean, you know, you can make it as complicated as you want. I mean, on the screen I have right here a similar demo again with the in this IPvo presenter window. I have an Arduino. Actually, there's two Arduinos. They're for two different demos. The one on the top is just a regular Arduino Uno, and just like in the previous talk, I have a potentiometer, which is a variable resistor. In this case, I have three to control three different axes of a visualization over here. That's a picture of Homer Simpson in this case. Each one of these variable resistors is going to control the amount of electricity that flows, and that's then measured by the Arduino, which is then turned into an animation of this little orange ball that's sitting in front of Homer Simpson. I'll first do the demo, and then I'll explain a little bit more of the details. So if I turn this first variable resistor, the ball is going from top to bottom. This is all the way, you know, +1, and then this is all the way down to -1. Okay. If I do the second one, I can go from left to right. So that's, you know, different x, y, z. This is the, I think the y value, and then this one is, you know, going back and forth. So going, actually, it's already at the very farthest away that it's going to be, and so you can only make it go closer and closer until it gets all the way. Well, it goes all the way into his eyeballs in this case. And let's just, that looks weird, so let's put that back out again. So what that is doing is, this is the notebook that you know, that it runs from. There is a device open that connects to your serial device. That's this black cable is basically a serial connection, and in this case, um, I'm using a Windows machine, so it's connected to COM5 um, at a specific baud rate. And this, just like in the example earlier, is just a task that's going to be run every so often. In this case, it's run every 0.2 seconds, and all that does is um, it pings the device and then it reads back the values, the settings of these variable resistors. And once it gets that position, it rescales it. Basically these values go from 0 to 255 when they come from the serial link, and I rescale them to run from -1 to 1. And then I remove any existing scheduled tasks, and then I run that scheduled task. And then this little section right here is just a graphics 3D which draws Homer Simpson, and it uses various dynamics to update its eyeballs and the little ball in front of him, and the lighting situation is also dynamic. So this is an example that came from the community. I've adapted it a little bit, but I hope that kind of answers your question. This you can make any visualization, using these gauges. You can make it as complicated as you want. See, there's no other questions yet, so feel free to ask any questions you may have. This was just a little demo of using the Arduino. Another example, this is related to Raspberry Pi. So I have a Raspberry Pi with a camera sitting in my office, and in this case, I have it set up so that I run a scheduled task every 360 seconds to take a picture out of the window, the office window where I am. And every time I do that, I take the picture and I save this to a cloud object. This is a new feature that's going to be coming in Mathematica 10, which hopefully will release very, 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 very soon now. The Mathematica 10 will include support for cloud objects and cloud connections. So what I'm doing here is I'm connecting to that cloud. I'm creating an image, and then I create a cloud object, a named cloud object, in this case that I call RaspiCam, and then I just save. So instead of saving to a file, I save to the cloud, so that I can then read from that cloud object from any other place. So I can show you the setup for the Raspberry Pi. So that's sitting right here, and it's pointing out of the window, towards the Champagne. I think it's called the assembly hall. And so, in principle, if it takes pictures every 5 minutes, then it should have an updated picture now. So I'm going to reevaluate this input. And that picture should change just a little bit. Okay, that may not have been completely obvious, but there was a red car here that's now gone, and this car right here on the screen was not there earlier. So what it allows you to do is basically, have a device sitting anywhere out in the world and just, take pictures or take measurements and, send that over wireless over the internet to the Wolfram Cloud, and then you could review the results, from your laptop or from any other computer. So that's going to be very easy to do in Mathematica 10 using the Wolfram language. See, there's another question. Do you have a code snippet for how to connect to an Arduino Raspberry on a Mac? To connect to an Arduino, I think this is also in the community. There's examples of that. What I usually do, the key part there is let's see here. To connect to a device, you have to do device open and then serial, and then you have to give this port. And to figure that out, that's not totally trivial. But what you can do is, what I usually do is um, I open the Arduino IDE, and that will typically tell you the port that you can connect to. It has some logic to figure that out. Um, on a Mac, this works as well. There may be other ways to do this on the Mac. The other way to do it on Windows, at least, is to use the device manager. That will also show you a tree of every single device that's attached to your, active on your computer. So that's usually the easiest way to get that. But these ports do change as you reboot your machine or as you plug it into different devices. So you do have to kind of, figure that out. Um, I'll do one more quick demo of the cloud. So this Raspberry Pi was a very simple example of the cloud. Um, what's really nice about the upcoming cloud product is that it allows you to do any computation in the cloud. So this is an example of that. Um, and this is related to the second Arduino, the Arduino Uno that's over here. And so what this does, this is just a single LED light over here that I can turn on and off by sending a command to the cloud. So what this Arduino Uno is doing, it's connected to the internet through this gray cable here. It also has Wi-Fi. And all I'm doing is with a different application, for example, from Mathematica 10, or in this case, I'm going to use this Android application, which is a simple application that talks to the Wolfram Cloud. And so I'm going to press this speak button, and then I'm going to say on, and that will change the state in the Wolfram Cloud, and it will hopefully turn this LED light on. So let me give that a shot here. On. Okay, well that didn't work. This was working like 5 seconds ago, so maybe it's not plugged into the internet. Oh, and yeah, the light on this Arduino here went on now. I think it got disconnected from the network. So let me try this one more time here and see if I can turn it off. So it's on right now. Oops. Off. Okay, and the light went off. So it's and the idea there is that you can do a certain computation in the cloud, and this is probably a good way to pass things on to Chris Carlson. This is a very simple example of something what's called an API function, which allows you to just write a piece of Wolfram language code, any Wolfram language code, and you just stick it in the cloud. It'll give you a cloud object that you can then call with parameters. So basically, that's all I'm doing right here. I'm basically saying, okay, if it's on, set the state for the light on in the cloud, and if it's off, turn it off, and then it will, the other device, in this case the Arduino Uno, will basically, pull the cloud and update its states accordingly. So if Chris is ready, are you ready, Chris?
I'm here. Okay, this is Chris Carlson again, and I'm going to give you a peek at what the Wolfram Cloud looks like. This is functionality that will be released soon, and it's under very active development right now. There are developers in the building that have their fingers in this code at this very moment, so things can change at any time. I'll try to give you a demo, but things could break. I may have to switch to different servers or try things repeatedly. But with any luck, I can give you a little bit of a peek at what the cloud looks like. So Arnaud gave you a little bit, um, showed you a little bit of things running in the cloud. I want to show you another way of working with the cloud, or several ways of working with the cloud. So let me sign in first. I'll sign in as me. It's signing me in. And the first thing you see here is the home page for the Wolfram Programming Cloud. And I'll go here and create a new notebook. So any of you who are familiar with Desktop Mathematica will be very comfortable with this interface in the cloud. This is a cloud notebook, and it works pretty much like a notebook does in Mathematica. You type in an expression and hit Shift Return to do an evaluation. It goes to our servers and does a calculation and sends the result back to the notebook. Things like, for example, graphics work in the cloud as well. And 3D graphics are interactive. You can rotate and so forth. Even manipulate works in the cloud notebooks. Manipulate x from 0 to 1. And you have sliders and so forth. So if you're familiar with Desktop Mathematica, you can use the same notebook interface now from within a browser in the cloud. So that's one way of working with the cloud. You can develop things in notebooks in the cloud. Another way is to deploy things to the cloud. You can store data in the cloud. You can put programs in the cloud and give other people access to them via the cloud. So a very simple example of that, probably the simplest one, is say cloud deploy of a string, hello world. And now this is depositing that string in the cloud, and it will return a URI-based URL. And if I click that, it'll go to a page that says hello world. Okay, we can make that a little bit fancier. We can add some style here, say make that 100 point and make the font Helvetica. And let's tell it to make a PDF out of this. So we'll say export form and PDF. And now we have a new cloud deployment. And if I click on that link, I'll get a nicely formatted hello world as a PDF. And I could, for example, save this web page locally, and I would have a PDF of hello world. So those kinds of static deployments are not particularly useful. What's more useful is to deploy things that actually do some interesting computation in the cloud. Let me show you an example of that. Before I get to that, let me show you one other thing. So this notebook interface not only works similarly to the desktop Mathematica, it is in fact completely compatible with desktop Mathematica. So I can take what I've done here and say download this. Right, it'll download here, click this, and now, let me bring this, now I have, this notebook is now running on the desktop in my desktop version of Mathematica, and I can make changes here. Let's say, I don't know, put a plot here at the top, and save that notebook, say my cloud notebook. Let's put it on the desktop. And now go over here to the cloud and say upload what I just saved. And let's upload that. And now I have that notebook in the cloud with the plot that I added from the desktop. So you can very fluidly now work back and forth between the cloud and the desktop. You can do things in the cloud. You can send them to people that have the desktop version or vice versa. Okay, so let's get back to cloud deploy and some more interesting kinds of deployments. So let's make a cloud deployment that actually runs a program in the cloud rather than just returning some static data. We have chemical data built into the Wolfram language. And if I say something like aspirin, and give me the structure diagram. Okay, this will go out to the our servers that have chemical data databases in them and give me the structure of aspirin as a graphic. There we go. Actually, let's make this a little more interesting. Let's make this a carbon-hydrogen color structure diagram, and that'll give us a little more embellished graphics. Okay, so let's deploy that to the cloud. And let's make this a PDF. Well, let's not. Let's just deploy. And we'll make an API function, and I'll explain this in just, or let's make a form function. And I'm going to give it an argument compound, and it'll be a string. And instead of aspirin here, I'm going to tell it to use the value of the compound that was entered. And if I have all of my brackets lined up here properly, this ought to deploy to the cloud. And now I have this URI. Let's visit that. And now it's created a form for me in the cloud that I can type a parameter into. So let's say caffeine, and I hit return, which will submit that to the cloud. It'll do the computation, look up the structure of caffeine, and should give me a PDF of the result, and there it is. That's nice. So Arnaud showed you a very simple variant of that. Is all you do is replace form function with API function and redeploy it, and now I get a URL where you specify the compound that I want the structure of in the query string to the URL. So if I visit this URL and then add here to the end compound equals ibuprofen, and that should give me that structure without a form. There we go. So of course these examples are very simple, but any computation that you can do with a Wolfram language you can deploy to the cloud and make accessible to anybody who has browser access to the internet. There are many more things that you can do in the Wolfram Cloud. You can schedule tasks to be run at regular intervals. They can generate reports using templates that you also set up in the cloud. You can store data in the cloud that you update, say from devices that you're querying and so forth. Many possibilities. There are examples of the Wolfram language and many including deployment to the cloud here. So if you go to wolfram.com/language/gallery, you'll see this page. And there are lots of examples of the kinds of things you can do with the Wolfram language, like blur faces of an image, make a plot of the path of the sun. You can recognize handwritten digits. There are lots of examples here. And many of these include examples of cloud deployment. So for example here, make a weather dashboard, shows you how to make a dashboard that'll give you the temperature or the current weather conditions at your location. And each example will show you the complete code at the top, and then it has a discussion which shows you exactly how that code works. And once the cloud is deployed, which will be soon, we hope, you'll be able to click this button here, open live version, and it'll take that code in the example and drop you into the cloud in a sandbox where you can try it out, you can experiment with it, you can make changes, you can see how it works. Meanwhile, you can, if you leave your email address in this bucks, then we'll get back to you as soon as the cloud is deployed and ready to go. So that concludes our workshop, and on behalf of our developers and the Wolfram staff, we hope you enjoyed the presentations. At this time, we'll move to the chat room to answer any further questions you might have.